So here we are with another installment of the podcast, and we have Hermes here joining us. And Hermes has been in the industry for a while and is an engineer, and I think it'll be really interesting to talk about and hear Hermes' perspective on solving issues from a technical and design standpoint from the manufacturing side. I think a lot of
Right.
times you see an engineer of record and consultants sort of playing that independent role on the project team. And difference being that a lot of your business is built around working directly for manufacturers and subcontractors. So I'll ask, has that always been the case? Did you know early on that that's what you wanted to focus on?
Well, not really. I mean, the way I stumbled into this was kind of, sheer luck. Just I'm a mechanical engineer by trade, and I was working in a company in Orlando that was doing custom manufacturing equipment. So from there, I did get honed in like a lot of the services that I provide now, where it's like, trying to understand what they're trying to achieve, what they're using, what their mindset is, and what direction they want to go. So when that company closed their doors, then it was like, okay, so what's in the vicinity? I don't want to uproot the family. I don't want to go somewhere. And so I stumbled into this certification business, and came in, and honestly, I was green as can be. I couldn't figure out what a mutton was, what a jam, a threshold, mullion. I mean, all that was like completely foreign to me. But once I started getting into like the nitty gritty of it, like, okay, these are simple beam calculations, stress analysis, very familiar to me from what I've been working previously. So, and then, that kind of just fell in place where I understood from my background what the manufacturers had to go through when it came to product development, design, manufacturing, installation, training, and all the other, facets of manufacturing when it had, when we come up with the decision, oh, you have to change anchor spacing, you have to put the glass this way, not that way. So it creates this whole mess of like ripple effects just from one decision that, let's say, as a consultant or an engineer, I would make based on a field condition or something else, where now, where they're trying to like jump through hurdles and try to like achieve something that, for me maybe sounded minor. So we made it a point to like part of our culture here or structure of our business is to integrate ourselves with the manufacturer's business and then just kind of fill in the voids and try to make sure that we're just giving answers and we're supporting them to make sure that they can like move forward more intelligently with their decisions and making sure they don't feel rushed or you go forward with testing and becomes this big awkward situation where they're failing and so just that they were ill prepared and they weren't understanding what was going on.
So I remember last time we spoke, you mentioned this, and it's what just went through my brain is how you look at all these members as, I mean, at the end of the day, when it comes to structural analysis of a lot of these systems, you're working off of deflection criteria based on whatever the building code or the project specs are working within. But how you just described is looking at every member as a simple beam. I
Yeah.
struggled immensely in my statics course. Uh,
Yeah.
I didn't pass the first time and had to take it a second time, and I wasn't as engaged as a student. And I wish I had a little more appreciation
Yeah.
for kind of real life application at the time as a student. Did you feel like you had a really, really strong engineering foundation before getting into this industry, and then it was easy to apply all those principles?
Oh yeah, yeah. It's again, it was just kind of always trying to figure out how to relate, how to connect the dots, right? I mean, I was always good with Legos and puzzles when I was younger, right? So putting things together, working with my hands was always something. I can envision things in my head before I can actually put it, in practice or whatnot. So I think that all kind of helps in sight, but absolutely, I mean, just going through, it's always the game of like the hip bone is connected to the leg bone is connected to the knee bone. And so a lot of times you're looking at systems because again, it's we're looking at components and figuring out where like the path of most resistance is in this case to make sure that everything is rigid and sturdy and sustainable. But it is something that you start having to look at. Okay, so from the anchor to the frame, from the frame to the gasket or silicone joint, and then from there to the glass, and then how does that transfer to locks and hardware? And then you start going like, well, from this point to that point, if we analyze, what's going on here, then okay, let's figure out what's the worst case scenario here. Okay, great. And then you kind of like dissect and break it apart. So then you get an overall kind of like a grade of what the system should perform to and behave.
When you talk to people who are completely outside of the industry, when they think about structural failures, I mean, I think the scariest thing people can envision is like a structurally glazed curtain wall, and if you don't have good adhesion, or if the silicone fails, God forbid, the glass falling off of the building. But past that, when you're talking about kind of assemblies and framing members and anchors, you don't really see a lot of like catastrophic failures in that sense. Do you think from a design and engineering standpoint, there's such a significant factor of safety built in, that for you to really see that, like even if they get the fastener spacing wrong or use the wrong grade or bolt, the likelihood of something like that occurring is still so low?
Yeah, I mean, remember, we're down here in Florida, so the advantage that we have is that there's a lot of history already of catastrophic failures. And so we've learned as a community to expect that we need to bring it up to a higher standard. And so most of the failures that we would see are at the lab, at the level where like we're either doing more research and development, or it's something that a product is coming into the market, and then we are at the lab for the purpose of vetting it, making sure that what we calculated on paper in theory, it actually translates. Like, for example, we had a sliding glass door, for example, that the interlock was bolted on to the style extrusion. So then it was a modular system, so it could work, as an interlock, as a astragal, biparting, and whatnot. So what happened? The screws weren't attached properly, or it wasn't, enough, right? And so what happened is, we went through the structural test, pass, impact, pass. When we started with the cycle test, there was so much fatigue into the anchoring and the wall of that aluminum extrusion that once one of the ends started coming off, it just like a zipper just pulled out, and the whole thing just basically disintegrated. And so we're all kind of flabbergasted at what just happened. And those are little things that you're like, oh, well, I assumed, or, we assumed that those things will work together, and that's the strength of the system. But it's just those little flaws and little things that you have to consider, as well as you're looking at the design of the product and how everything, again, transfers. So I'm connecting to here. I always tell my guys, like, it's like thinking about electricity. You got to look at how the load will ground out into an anchor, into the ground, right? So into the substrate. So if you have wind on the glass, what is the path of where that electricity or the force is going to go? And, a lot of times we'll catch some of these things, but, testing is definitely part of our like practice, because there's a lot of things that individual components may look like they work in unison, but then once you have the dynamics of flexing and stretching and just kind of racking, there's a lot of other things that will come out that maybe not expected.
Just to play devil's advocate, if you think about like the scrutiny of buildings today and the rigorous codes and testing that we have to overcome, and the design criteria, how many existing curtain wall buildings, hand laid brick with block punched window buildings, do you see that were built in the 50s, 60s, 70s that are still there and are still holding up? I mean, I talk with some guys here, some of the veterans who were installing or replacing windows in the 80s, and they're like, we didn't calc out the fasteners. We just threw on a bunch of, strap anchors and sealed it, and it's in place. So, I mean, and maybe you have a little bit of a differing perspective on that, given I know there's a lot of scrutiny right now on the existing building infrastructure in South Florida, given there's been some recent events. And so is it reshaping the way people are viewing existing buildings and their overall integrity?
Yeah, of course. I mean, there's obviously that sense of responsibility. You obviously, as part of a designer or professional engineer, you want to make sure that life safety, public safety, and it's all like our primary purpose here to make sure we're looking out for the better interests of society. But there's so many other levels or layers of how a product gets designed and assembled, fabricated, installed, and then inspected and then maintained. right? So then there's a lot of things where, a lot of the things that were in the news or, came out, in recent years for failures or these catastrophic events, it was just a matter of then the maintenance. It was just at the end, that end part where, there wasn't a budget for it or it wasn't a priority and so obviously then it goes back and then everybody starts going for the forensic and looking at other things and the design, and sure, then there's older codes that have been grandfathered in, and so then now you're working with maybe a handicap already knowing, coming into it. But that's why we have the 40-year inspections, and probably now it's going to be a 30-year inspection, and there should be more, requirements on the management of the building, so they're they can enforce some of these upgrades or maintain a better quality of the structure. But at the same time, when we're talking about product design and product installations, anchoring, and like going back to just that individual system or product, yeah, there's test reports or testing that we'll see that just they'll take the screws out and then they'll run the test again, especially for like the non-impact stuff, and the silicone alone will hold the system in place, right? A little bit more flexible, more movement, but still the silicone has evolved so much. You use silicone just to hold glass on curtain wall. So when you're looking at other type of applications, the silicone should be also as applicable. But the problem that I always see, or like what I point out, is we use mechanical anchors just because we know that there's more reliability, there's more consistency in the capacity and the resilience of that, versus trusting on the contact surface, the quality, how much silicone did you actually put, which then becomes more of an opinion or something that becomes open-ended. If you say, how much silicone did you put? Well, I put like 1 tube, 2 tubes of a caulk, right? Or how many screws did you put? Well, I put number 10s. They were like fastened at 1.5-inch embedment, and they were at 12 inches on center.
Easier to inspect and monitor.
Right. So then that becomes also the norm, obviously, because then now it's something that it's a kind of like a benchmark that everybody has to meet, right? And so, yeah, it's easier in that sense.
When you go to Florida and see a lot of the new construction, it's very common to see unitized curtain wall and very large fixed spans. I've seen buildings with you and you say, oh, 12 feet tall, that's normal here. And so, you see the kind of rinse and repeat type of buildings and designs. But I guess from a glazing standpoint, what are some areas that you want to see the industry improve upon?
Well, I mean, there's, like you said, it's a lot of like rinse and repeat, rinse and repeat. There's always that standard 6-inch, deep, 3-inch wide mullion that you use, everybody's using, and the same door styles and product. And it is an easy way to get into the market and just like see what the other guy did and put it together and all that. But it is, there's so much more now materials and products that like innovation that could be also put in place. Again, I know we're in hurricane country, and that's just kind of like the norm to like just make sure it's strong, it's rough, and it's something where it has that I guess I would say that lack of tolerance in a way that you can just make it so it is something that robust enough that it will take a couple of hits and keep on ticking, right? Like but at the same time, those are the things that we're gonna kind of keeps us a little bit behind in the rest of the country. Like when we start getting into the thermal and some of the other code advances that you see in other states, California, New York, based on that it would be nice to have here. I mean, I know I've heard in some of your podcasts, about the sweaty windows. That's something that obviously at the long term, everything is concrete and everything is aluminum and steel. So, maybe the water, the moisture and like maybe mold is not as an issue with that type of sweaty window effect, but it is a nuisance, and it becomes it will affect the laminated glass at a point where if moisture starts creeping into like the laminate portion of it, you'll see delamination, fogging of the IG units, and all those are like long-term effects of just that little thing. So then, the thermal breaks, okay, then they're not as strong as just a solid aluminum piece and things like that, but there has to be maybe a kind of like an acceptance of like there is more than just this one way. And the biggest thing that we're seeing in the industry now is then a lot of the European companies coming in, right? So for the past maybe, we've been at this, for 17 years. So I would say past 8 years it's like the big drive of these Italian, German, Swedish, Swiss companies coming in with their steel or aluminum thermally broken systems or minimal systems that they're used to making these 20 plus high, tall windows and doors. And they come to the market, obviously, as a culture shock, and they're like maybe thinking twice if they want to keep doing it. But we've had some success rates on that front, right, where we start in Orlando, and then we start kind of trickling down to doing some, impact testing. And at this point, we're in a project that it's pretty aggressive, and we're talking about 120 PSF plus with a minimal system. But it's something that we are looking at. It's interesting, and this is the challenge, and we want to make sure we break new ground. And so we're looking at maybe the glass as more as a structural component than just the infill, and then the aluminum, is more the reinforcement to the glass. And so those are things that we're trying to change the mindset of like, hey, let's look at it this way instead of like the traditional way.
When you look at how we're building today, and I think Florida is one of the hottest construction markets probably in the country, there's just so much being slapped up on the wall at the moment that as an industry, we're very slow to progress and evolve, the building construction industry in general. So the next generation from right now, 20, 30 years from right now, what do you think you're going to look at with some of the building practices and say, what the hell were they thinking? Just like we were talking about in the 70s and 80s, how they were installing windows. Do you think in 20, 30 years, they're going to look back and say, how are they not putting in insulated glass or thermally broken frames in this, 50-story high-rise building?
Absolutely. I mean, just, you've been in my office. It's, these 13-foot ceilings, we have 12-foot high window wall systems, or curtain wall window wall systems. And, the ones that are facing the east, I mean, they're in heaven. I feel bad for the guys over there. We put window treatment and all that, but it's all interior. So anything, we're still kind of like trying to manage the heat, the radiation, but the heat still comes into the building. So then we're cranking air conditioning and all. So there's a lot of things that, inefficiencies that could be improved for sure. Thank God, energy for us, the cost is very low and compared to other countries and things like that, but it may not be, in 20, 30 years. There may be other things that we have to consider too, like with, water level rising, and, we're doing some other things, with regards to the construction around here in Miami, especially in South Beach and the lower ports. But yeah, I'm sure they will. I mean, I say that already now, when every time, we're looking at these type of constructions where it's just, you see very large gaps in between the frame and the substrate, and we're no thermal breaks and just laminated glass, and we're like, wow, I thought we could advance a little bit more. Every time we go to the European trade shows and things like that, you were like, they're so much more far forward in thinking of like modularizing and putting things together where it's not just this individual window, individual door, and then we're just kind of like slapping them together, and it looks all right, and so it's things that like that thought process of like how to make this something that could be more kind of like aesthetically obviously more pleasing, but also it's something that it works together as the envelope of the building, as like the water air barrier of the full building, because that's at the end of the day, you want to make sure that whole interior environment is comfortable and it's safe and healthy.
Yeah, at the end of the day, there has to be incentive and motive for the owner to want to spend that upfront money to do adequate modeling and detailing and consulting and ensure that they're getting a whatever they deem high performing envelope, because the question becomes, are they paying the heating bill, or is it the individual tenants? And so that's going to ultimately determine potentially what the ROI is on their facade, or how much they want to spend on their mechanical system, or how seriously they take it. Instead of just looking at it as let's just hit a code requirement, because I think you can possibly hit code without doing a non-thermally broken frame. So if everybody's just looking at it like we just need to hit code and that's what's being enforced, there's no real motive to spend more money. where it's not needed.
Absolutely. And when it comes to the thermal requirements, it's even, I would say, in my opinion, it's not as enforced. I mean, the thermal part is more pushed by either a homeowner or is going to be by the architect to meet certain design criteria or levels recognition than actually, something that's code enforced. We're all focused on structural impact, and everything else is just kind of like, yeah, okay, just ticks off the checklist, but it's not something that it's part of thought through in the design and the whole process. So.
When it comes to insulated glass versus just a standalone laminated, do you think there are any drawbacks to going with an insulated assembly? I mean, if you think about the lifespan of a laminated unit, as long as your interlayer doesn't fail, there's no reason to think that that unit should fail after 20 years, where a typical insulated unit, at some point you're going to have the argon is going to seep out, and you might get some fogging within the unit, and at that point nobody wants a fogged up light, so you're going to have to replace it. So the thinking about the lifespan of an IGU versus a standalone laminated unit.
Yeah, no, you're right. And then you got to think about too, like where you have, let's say, technically, down here with or anywhere that you would do wet glaze instead of dry glaze. If the IG unit or it leaks, then you got to replace the glass, and now you have to like go through this whole removal process trying to get the silicone out, and so it's a big ordeal. A lot of times you just end up damaging the system. You have to replace the whole thing. So yeah, I mean, it's added weight as well, when it comes to having that extra piece of glass and things like that. So having the laminated glass, if, like you said, it serves a purpose. So you have impact, maybe some of the acoustical, just soundproofing and things like that, and then having an IG unit is just more of just kind of a dressing of sorts, because the frame and everything else wasn't designed to like just be completely thermally improved or thermally insulated. So then again, it's just something like, oh yeah, I have insulated glass, and for the most part it could be further up north, and then that's where maybe Orlando or something where it does serve a purpose, and the way the application is done there, then it's dry glaze plus potential, because now at that point it's considered a non-impact location. So then it's a little bit more practical to have the insulated glass and have the use for it. But yeah, when again, this market is very hard to I guess like to change or to like try to like steer towards a different mindset. So Lamy is still kind of like your first choice, and even if you get into Orlando, they'll go for like just tempered. They'll start with the discussion of like 1/4-inch tempered is all we need, right? Okay, let's just hold on a second.
So what happens when you get outside of Southern Florida and you get into Northern Florida, where I know the requirements start to change, and then you get into other areas like maybe the Northeast, where you're still having a design around impact, but the requirements are different. At that point, does it become much less stringent, and your requirements in terms of where you need large missile versus small missile versus potentially non-impact? How would you compare Northern Florida, let's say, which is a little less stringent, to other areas of the country?
Yeah, it's obviously, like you said, what's the code requirement, and then you start looking at in recent years how the environment and how the weather has changed and kind of up their own, the weather, Mother Nature has kind of upped its own beat, where where we would have on maps in the everything in everything in this North America is based on the IBC, right, the International Building Code, and then every state then takes on that some version of it, and then add some of their own requirements based on their geography and typology of where the states are. So then anything above 130 miles per hour will be considered a hurricane prone or windborne debris type of area. And so as you start going up the map and you see the wind maps, Mexico City, right up in the panhandle, that's considered a non-impact location. But a couple of years ago, Michael or Matthew came through and ravaged through. So then it's something where you start going like, well, it's, yeah, the code says this, and maybe the minimum requirement is that, but consider even if you're just considering maybe a different market than just what you're focusing on the current project, your current need, but times will change, and then let's just make sure we prepare for it, right? But it is something where as you go further up in Florida, you still have the stringent like inspections, and you have like people making sure that everything follows the Florida building code, installation instructions or Miami-Dade NOAs. So Florida is still, pretty good about that because all their building code officials are trained that way in the mindset. But as you go up further north, and now you cross the border over to Georgia, Carolinas, and then New York, then it's something where I feel sometimes as the kind of I'm like the Jimmy the Cricket. I'm the consciousness of like, you have to consider this or that. Oh well, it's only 30 PSF but still impact. You have to consider certain things. ASTM, which is pretty much what covers all North America, and then ASTM 1996 is the impact protocol. Splits the missile requirements and the speed of the missile and all that in levels. So that way, if you start looking at anything 170 miles per hour or less, it's only one impact on the infill instead of two, like Miami-Dade would require. There's no impacts on mullions or mid rails or anything floating in that sense. And then as you go lesser wind velocity, then the requirements start reducing as well. And also as you go up in the building, up to 30 feet, large missile, which is the typical 2x4 9-pound missile. And then as you go further up, then it's just a small missile, which is just the 2-gram steel pellets that get thrown to the glass or infill or whatnot. So yeah, so there's as you kind of like go further north or north, it's almost like you're peeling off more and more requirements. So people kind of like, I feel like they get comfortable, they fall asleep, they forget certain things as they happen. And then when it happens again, they're like, oh, what happened and what's going on? We need to improve on our codes. And well, the standard was already there, it's always been there. It's a matter of then just making sure people remember that, these are the steps that need to be followed. And there's a lot of things that the newer generations, I think with a lot of the computer technology simulations, and people are depending a lot more on the technology, on the computer to tell them this is right or wrong. And a lot of times it's just a common sense or just a common practice, just thinking through the whole process of what needs, what is important, what's safe, and what's necessary.
So with a lot of these overseas suppliers and manufacturers coming into the market, not only Florida, all over the country, how are you finding them digesting and developing systems and just approaching projects with potentially a lack of familiarity around our building codes or ASTM standards or AMA standards, and receiving a spec document that's fully integrated with our means of building, and then they're going to say, all right, well, we don't know what we're reading. We don't know what to make of this.
Yeah, no, I actually have had what I call like I've created documents where it's just kind of like a translation. It's basically an equivalency document, I say, like, because all the European EN standards that the companies from overseas have to go through, the protocol is completely different. It's different steps, different fail points, but in a way you can kind of figure out what the commonality is between their air test and water test and structural tests and everything. So then it's something like we have to create basically a table where it's like, these are the ASTM standards, these are the EN standards, and then these are what they, these kind of cross-reference and how one could read the other. So that way, at least an architect or somebody that's receiving the bid package from somebody from overseas can say, oh, okay, this is similar to like a residential type of rating or something like that. But for the most part, a lot of these companies from overseas, they, granted, they have like their tenure, they've been able to successfully, do construction and all these big and very much maybe considered landmark buildings in Europe and whatnot. But when they come in here, they almost have to have like they have to like eat some humble pie, because it's something where, there's a lot of other things, different ways that you think, that you have to understand what the code represents and the requirements. And there's a lot of the testing, even if it's just like NAFs, for the non-impact products and things like that. There's a couple more, kind of supplemental requirements and tests that they don't consider or put in place.
So do you find that their standards for the most part, are just as rigorous? It's just an exercise of translating a lot of it, or do you find there's a lot of or some missing components that they pay attention to that are highly scrutinized or emphasized here?
Yeah, I mean, I know the fire codes for sure over there are seem to be more enhanced, and especially with, their automation and things like that. They'll have, they understand that smoke is going to be the first, the first killer of anybody in a building is the smoke, not the fire. So they'll have systems in place where they automate certain open, they'll vent out or open doors and windows on purpose, even though maybe it'll feed the fire, but then it creates a current that will, take the smoke out. So at least people have time to go out and not have to inhale it. So things like that, absolutely. When it comes to like air, water, structural, like their requirements on wind loads are I would say more similar to like New York and California. So it's like, that 30 PSF, 40 PSF. So once you start getting south of that, then, they will have to like kind of adapt or look at things a little bit differently. Material wise and product wise, that we do a lot more testing, I think, as well, when it comes to the plastics, the composites, and making sure that they're more, lead free, more suitable and et cetera, things like that. But when it comes to like the thermal capacities and all all the other part of it, then yeah, that definitely those materials or those specifications for them, it's a lot higher, again, because mostly the energy costs and things like that are higher. So then they have to consider that that's where the passive house and the net zero type of design comes about, because they need to figure out how to make the home or their structure isolated from the environment at almost zero cost, because the energy costs are so high.
It's strange that we are so far behind when it comes to fire protection, and I think it's a hot topic, but the question becomes, when we're building so rapidly and quickly, how do you implement this major change, which might require complete modification of systems for the way we build, or how you fire safe a perimeter slab, or what materials you're reinforcing the mullions with. So do you it's good that you touched on that, because do you think that's going to be sort of a major pivot that we see, and in 5 or 10 years, a lot more scrutiny around, not just in Florida, but nationwide?
Yeah, I hope so. I mean, unfortunately, especially with California, right, having all these like major fires and things like that. Where, I mean, granted, it's not going to be in a major, a major city or anything like that that's going to affect, the metropolitan areas and things like that. But still, I mean, you see in the news, there's a lot of homes and a lot of things that get affected by it, and it's something where there would be maybe some adjustments on that, or more advancements on that code requirements. But unfortunately, human nature is going to be again, it's reminded or recalled when a major event happens, and then everybody kind of stops and thinks, okay, well, how can we do this differently? So it's something that it's a burden on financial burden. It's a it goes into the material costs, it goes into the labor costs, it goes into all these other I guess supplemental services or costs at the end of the day. So a lot of times we're kind of like the rudder on the Titanic. We see we'll see the iceberg, but we can't really steer it until something does hit it and changes its own course. So unfortunately, that's where where we are at. But I hope so. I mean, there's a lot of things where with fire, a lot of things are again with flooding, that's something that's also happening, where you see hurricane is just kind of like the catalyst of some of these water damage or flood damage that's being caused because of high rising the tides and things like that, where people are not thinking about it, and it is an issue. So then there could be, we were thinking about, we had a call with a customer where they're like trying to do some type of pumping system through the mullions of the curtain wall system, something where like it can just help, from water coming in, and or people were, thinking, well, other companies were looking at like, we have a thermally broken system, but can it be also fire rated? Can we? So it's almost like we're kind of layering two products together, and each one has its own purpose, so there are things that, people are thinking about it. They're putting it together. We're helping kind of put it on paper and figuring out what that really will look like, but costs, and then who's going to pay for it, and how is this going to be made more attractive? And, so there may be some customers like in the high end, single family home type of market that, they're willing to pay that extra price, and because they want to have this shiny new toy to show off, hey, check this out and that. But it's, unfortunately, it's not mainstream. So that just creates a more of a lag and deterrent when it comes to like trying to bring these new innovations, even if they're already existing, let's say in Europe or somewhere else. It just doesn't fit the mold here just yet.
Yeah. Yeah, everything's driven by cost today. And I think until we find ways to reduce cost of, typical assemblies, like, until we find a way to make triple glazing more affordable at scale, you're only going to see it mandated in climates and regions where it's required by code. And it's the same thing with a laminated assembly. Even if people want better acoustics, we have OER requirements in New York where we can't hit the OITC values without using laminated glass. So that's why on so many projects it's not impact rated, or has to be impact rated, but you see laminated just to hit the acoustic requirements. But again, that's because it's driven by code. So
of course,
unless people have to do it, they're not going to want to do it.
And that's where the catch-22 comes in, because the cost of production fabrication will decrease as demand increases, but then demand doesn't increase until the price drops. Right. So then we're caught in this loop, right? So yeah, it's always.
What's the best way for manufacturers or anybody interested in working with you to reach out?
Well, I mean, we're buildingdrops.com, so you can always reach out, see our website, and our numbers are there. They can contact you as well. We're based in Miami, so we're very much in the industry here, local. Whether it's networking through labs or some of the manufacturers here. So we're always open to walk-ins and all that good stuff.
Hermes, thanks. This was fun. I appreciate you coming on.
Absolutely. Thank you for the opportunity, and congrats on the partnership with Schuco.
Thank you very much. We'll talk soon.
Absolutely. Take care.